The Milky Way has long been considered a fairly typical barred spiral galaxy, but recent findings are challenging that assumption and suggesting our home galaxy is far more dynamic, more odd, and far more alive than we assumed. One of the most striking revelations: astronomers have discovered a giant wave rippling through the Milky Way's disk, a massive undulation in the motions of stars and gas that seems to span tens of thousands of light-years. European Space Agency. This is not a subtle warp or twist in the galactic plane. It is a full-blown wave, like a stone thrown into a pond, sending ripples across the disk of the galaxy. The discovery emerged from data collected by the Gaia Space Telescope, operated by the European Space Agency, ESA. Gaia has precisely mapped the positions and motions of billions of stars in our galaxy, and by plotting their vertical and radial motions, scientists saw an unmistakable pattern. Stars between roughly 30,000 and 65,000 light-years from the galactic center are moving not only in their regular orbital path, but also up and down, in a coherent wave-like motion that propagates outward from the center. ScienceBlog.com. This great galactic wave cuts across the disk on an almost radial trajectory, unlike the spiral arms, and it displaces stars by significant distances above and below the midplane. Why is this so unusual? First, it shows that the Milky Way's disk is not just warped or wobbly. It's actively oscillating in a large-scale wave across a huge portion of the galaxy. We already knew the disk was warped, like the brim of a hat, and that it wobbles like a spinning top over time. Sky at Night magazine. But now we see that the wave is not merely a local phenomenon. It spans the outer disk much more extensively than previously recognized. The radial extent and coherence of the motion challenge standard models of galactic structure and stability. Second, the wave hints strongly at a relatively recent disturbance or collision. Just as ripples across a pond arise when something falls in, this galactic wave likely stems from an interaction, perhaps with a smaller galaxy, a giant dark matter clump, or a massive satellite galaxy passing through the disk. Some researchers suspect that the Sagittarius dwarf galaxy, or another infalling body, knocked our galaxy's disk out of equilibrium, setting it oscillating. Live Science. The Milky Way is not the serene, isolated object we once thought. It is being actively shaped by gravitational forces and past collisions, and the wave is a signature of that history. Third, this wave may affect how stars form, how gas flows through the disk, and how the galaxy evolves. A disk under such oscillation could influence the vertical motions of gas clouds, trigger star formation in unexpected regions, and alter the way the galaxy's thick and thin disks evolve over time. It means the internal dynamics are more complex than simple rotation plus spiral structure. There is a giant vertical and radial motion superimposed. In this sense, the Milky Way is behaving less like a stable, settled galaxy and more like a dynamic, shaken system still settling after a disturbance. To give a clearer sense of scale, this wave isn't a small ripple. Astronomers estimate that stars are moving outward at speeds of 10-15 km/s and being displaced vertically by significant distances. Scienceblog.com. The wave extends over many thousands of light years, far beyond our local solar neighborhood. Its origin remains uncertain, but its footprint is vast. It passes through the galactic disk, and the visualizations show alternating regions where stars lie above the midplane in red and below in blue. Eureka alert! This discovery adds to other unexpected waves and undulating structures in our galaxy. For example, the Radcliffe Wave is a giant filament of gaseous star-forming clouds discovered within our local arm of the Milky Way, stretching about 8,800 light-years and swerving through the galactic disk. Space. But the newly found Great Wave is much larger in scale and affects a far broader region of the galaxy. The existence of these multiple wave-like patterns suggests that undulating structure may be more common in galactic disks than we previously thought. The idea that the Milky Way is unusual comes into sharper relief when one considers that many models of spiral galaxies assume fairly stable, steady-state disks. If our galaxy is still oscillating from recent disturbances, it may be less like the average spiral galaxy and more like one with a dynamic, messy, recent past. It raises questions. How many other spiral galaxies are similarly distorted or oscillating without our noticing? Are many galactic disks far less quiescent than we assumed? If so, our picture of galactic structure needs revision. For us in the solar system, what does it mean? Probably nothing immediate in terms of day-to-day life, but scientifically it matters. The Sun is embedded in this oscillating disk, meaning that our local stellar neighborhood may have been affected by the wave's motions. Over geological timescales, the vertical motion of the Sun relative to the galactic plane may be influenced by these waves. Moreover, when we try to model the Milky Way's mass distribution, its dark matter halo, the orbits of distant stars, and the shape of the disk, such waves become essential inputs. Ignoring them would lead to incorrect models. And finally, this underscores a humbling truth. We may still be in the process of understanding our galaxy. Despite decades of observation, the Milky Way continues to surprise us. The discovery of a massive wave rippling through its disk reminds us that the universe is more active, more chaotic, and more intertwined than our textbooks often suggest. We are not mere passive observers of a settled structure, but investigating a living, evolving galactic system. In short, the Milky Way is unusual, not merely because it has a giant wave, but because that wave reveals a dynamic history, ongoing gravitational interactions, and an internal life that defies simple description. Our galaxy is not just a calm spiral of stars. It's rippling, moving, and alive. As astronomers continue to pass Gaia's data and future missions map the galaxy with even greater precision, we may uncover the full story behind the wave. What caused it? How often such waves occur, and what they reveal about the life of galaxies in general. For now, the Great Wave of the Milky Way stands as a dramatic statement. Our home galaxy is stranger and more fascinating than we ever imagined.